Okay, so I actually posted a PDF of a copy of these notes, but I'm just going to talk through a couple of things so that you can kind of nail down what's important. If you want to make flashcards for a kite and trapezoid, which we're doing next class, feel free. I have some you can have, just let me know. Kite does not have very many special properties. I have them kind of typed up here for you. The first thing is that you have two pairs of consecutive congruent sides. So instead of opposite sides being congruent, consecutive sides, so sides that are next to each other. So AB and AD are congruent, BC and DC are congruent. Also, one pair of opposite angles are congruent, so only one, not both. In this case, that's going to be angle B. So this angle here and angle D, this angle here. So the angles between the different sides are congruent. So B is between single and double, so is D, single and double. And they're congruent because of side angle side. You also have diagonals that are perpendicular, which is obviously really important because that's going to let us have some right angles that we can use. So I do know that these are all right angles. One other thing that's not actually typed here for you, these angles that are not congruent, A and C, they actually end up bisected. So A is the same as this side of A, C is the same as this side of C. Whereas the two that are congruent, B and D, those are not bisected. So with kites, a lot of stuff is going to come down to working with right triangles, working with triangles adding to 180, and knowing which angles are congruent. So looking at number one, since I do know it's a kite, they're telling me that, I can see that AB and AD are going to be congruent and DC and BC, meaning angle B and angle D are going to be the congruent angles. So I'm going to call them X since I don't know either of them, but I do know they're the same. From that, I know that 85, let me move that so you can see what I'm doing here. I know that quadrilaterals add to 360. So 85 plus 43 plus X should equal 360. Okay. If I simplify that, I would have 2X plus 128 equals 360. Solve from there. 2X would have to equal, let me type it in, 360 minus 128. So 2X is equal to 232. And finally, divide X equals 116. Since angle B and angle D are both represented by X, they both equal 116 degrees. Okay, so B is 116, D is also 116. On problem 2, you're going to want to use the fact that L is going to be congruent with J. So that means I know J is 82. And I'm looking for K, so I'm going to call it Y since I'm looking for just one of them. So again, 82 plus 82 plus 71 plus Y equals 360. And you would just solve for Y to find out what angle K is. And again, angle J was 82. Okay, Y, whatever you get for Y is what angle K is. I'll let you solve that or copy from the PDF. Okay, on number 3, again, I know P and R are going to be the same. And even though it's not bisected, I can tell you for sure that this portion of angle P, where the 37 is equal to this portion of angle R. Okay, so I do know that this is 37 and so is this. So I know that angle, let's see, QRT is also 37. PTQ is here in the middle, that's 90. Finally, for PQT, which is this one here, I can just subtract from 180. I can do 180 minus 90 minus 37 to figure out what that top angle is. So there's a lot of relating to 180. Okay, and if I do that, 180 minus 90 minus 37 is 53. Okay, so that gives me 53 for that last angle here. On the next one, make sure you use the fact that these two will be congruent. This little half angle is equal to this half angle. So let's see what we have here. GDE. GDE is this angle here, so it's 59 times 2, which is 118. DEH is going to be this angle over here, which I don't know right now. DGH is going to be the same thing, but don't forget we do know this is 90. So since I know the one angle is 59, I can do 180 minus 90 minus 59 to get both of those leftover angles that I'm looking for. So when I do that, it gives me this angle and this angle. So 180 minus 90 minus 59 is 31. So those are both 31-degree angles. Okay. So I think you should be okay trying 5 and 6. Remember, you're just working with a bunch of congruent triangles. Okay, so looking at this, I can tell you this triangle and this triangle down below are the same. Those are hard to trace. And then these two littler triangles are also going to be congruent. So if you find the angles in one, you can find the angles in the other. Same for number 6. On number 7, tells me WX is 14, so that's over here. And WR is 8. I'll make that a little bit smaller so it can fit in the picture. Okay, so WR is 8. I want RZ. So I want RZ, which is here, but I'm not really working with that triangle, so I'm just going to move it up here because I know they should be the same. Because I know that I have a right angle, I am just going to do 14 squared. Let's see if I can do squared. 14 squared is equal to 8 squared plus x squared. So Pythagorean theorem, I'm going to move the 14 squared to the other side. But you can solve. If it breaks down, great. If it doesn't, leave it as a root. For number 8, just so you can see how you would label it, AC is this whole thing. So I would chop that in half so that each part is 19. So this side's 19, so is this side. Okay, ED is 41. So that's this piece here. So still using Pythagorean theorem. This time I have 19 squared plus 41 squared equals x squared. Because x is that diagonal piece from that right angle. Again, when in doubt, look for the triangles. Okay, this side just practices more of the same. When you're trying to solve for like number 11, solve for x, I just have to remember that these two are the same, so I can set them equal. So 13x minus 32 is equal to 7x plus 22. It just wants x, so solve for x, you'll be done. Here for angle L, you would just have to solve for x the same way as number 11, so set them equal, and then plug into angle L. 13, since they gave us more information, we want to use the whole shape. So I know B and D are going to be the same, which means B is also 109. So instead of working with a triangle, I'm working with a four-sided figure. So I can say 5x plus 14 plus 109 plus 3x plus 8 plus 109 equals 360 and solve for x. It's long, but you just need to combine like terms. On this next one, I see angles, so I'm going to go ahead and mark that right angle because it looks like I might need that. I want angle STV, so I want this angle here, which will be the same as angle R. So if I can solve for R, I can solve for STV. So on this one, I am going to do 90 plus 9x plus 1 plus 23x minus 7 equals 180 because I am using that top triangle, so this triangle here. When you get x, plug into R, and that will go and give you your answer here. On number 15, angle FGJ is this. I know this is 90. I know that these two should be equal, so set them equal. So 5x minus 1. Let me move that so I can see what's going on. 5x minus 1 equals 2x plus 11. So I end up with 3x equals 12, so x equals 4. Plug in 2 times 4 plus 11, plus 11 is equal to 8 plus 11, so 19. So this angle up here is 19. Finally, I can do 180 minus 90 minus 19 to get the angle I'm looking for. And that is, whoops, 180 minus 19, 71. Okay, so this angle that I was looking for is 71 degrees, this angle here. I know these notes were kind of all over the place, but the full copy and PDF is on Google Classroom, so go ahead and feel free to fill in the rest, solve, whatnot.